Welcome to This Is My Architecture. I'm Matt from AWS, and today we're in London, England, and I'm joined by Bruno from Nice Software and Scott from Rockflow Dynamics. Thanks for being here.
Thank you.
Thank you.
So Scott, tell me about Rockflow Dynamics.
We're an independent software vendor. We create a technology called T-Navigator, which originally was a fully parallel reservoir simulator. It's now expanded, so it's almost a full subsurface technology. So it allows a petrotechnical engineer to do some evaluations of the subsurface to make good and safe and economical decisions.
Okay, so not everyone who's watching this is going to be voiced in the physics of subsurface analysis. So give us an example. What's a use case? How would a user actually use T-Navigator in the wild?
Well, T-Navigator, the best way I could give an analogy is it's giving you a weather forecast of what's happening under the ground.
Okay.
So you're trying to, first of all, make predictions on the fluid flow, whether it be oil or gas, and what that looks like over a lifetime. So typically, the end user, they're always constrained by time and computational hardware and software. These are always limiting factors in how to give best analysis to this uncertainty which goes on.
Okay, so there's a lot of data all the time, and you're drilling. It's real time in that sense. So new data gets introduced, the models may change.
Exactly. So then you have to bring this back in, and you have to update your models. So if you can have some hardware which can scale up, and you have a software which matches this with some interesting tools behind it, it really can take the burden away from the end user, so they can do more in less time.
So some companies are now moving both the visual elements like the UI effectively and also the HPC, the parallel processing, into the cloud. Have you started to see sort of cost savings, efficiencies? Like, what is this improving in the field?
We've seen some great examples of this being utilized to what we think is the tip of the iceberg. A particular example which makes us extremely excited is a particular company in the North Sea. They were looking at analysis of a subsurface, so trying to do a field development plan. There was almost an experimental project going on side by side with the typical workflows that they would normally do.
Okay.
This experimental project, instead of running the typical single base model as a group collective team trying to make best decisions, they took an approach where they took 33 geological realizations, a number of different uncertainty parameters, ran 64,000 cases. What this did was try to narrow this space of uncertainty. Now, the upside to the business was in approximately £1 billion. So this allowed them to, for example, plan how many wells they could put forward, the size of the pipeline, all these different factors were included there. So this is really a different step change into what's typically been used.
So billion is a big number there, so I just want to pause and think about that for a second. So they were able to not only condense the time it took to do this by scaling into the cloud, but they were also able to sort of increase efficiencies such that they save money, is that right?
Well, exactly. So in terms of the plan, in terms of infrastructure they use, etc., this was all savings. But the project, it was estimated that without using our software, without using the cloud, this could take in the region of maybe 2 to 3 years to do this analysis. In this case, it was just a matter of weeks. So it really completely changes the potential of what the end expert can actually do.
Wow, so let's turn to the tech magic that kind of helped to make this happen. So Bruno, your team at Nice worked with Rockflow Dynamics to build this system. Tell us about the tech magic that allowed these sort of efficiencies to be possible.
Yeah, leveraging the AWS APIs and ecosystem was very easy, and our challenge was about making every user interface, user experience easy for anyone that is completely new. Okay. So the capability to create auto-scaling clusters has been
These are the HPC clusters?
Yeah, this is where the solvers, the simulator is running, and we leverage the CFN cluster, which is an open source project from AWS, and we are able to instantiate an entire cluster, and together with the cluster also instantiate an OpenGL node that is running the interactive part of T-Navigator.
Okay, so this ties into what Scott was saying. There's sort of two components here. There's an interactive UI, and we were looking at T-Navigator on your laptop before. It's OpenGL, it's a 3D application. So how do you do that? How do you do 3D application streaming sort of remotely on AWS?
Yeah, we use DCV as a remote visualization component, okay. And we end up building this infrastructure on demand and dispose it when it's not needed.
So DCV is the application streaming protocol you use?
DCV is the application, yeah, remote viz technology, and Of course, we provision the entire infrastructure, and not just the operating system, but the applications, the libraries, everything.
Okay, so you're doing that with the G2 instances up here, and then you can stream it back to the user through a web interface, I think, right?
Yeah, it's completely web-based, and so you can go through a common web browser running on-premise, and you can leverage the infrastructure, and you can even do collaboration between multiple users running, looking at the same desktop or sharing at the application user interface.
Okay, so you can manipulate the models, you can see the visualizations in the software, but you also have to process some data. So when you submit the job to the cluster, where is this data living? Where is the data getting uploaded from? Where is it coming from?
Yeah, initially you have the data on the user premises, and you can have data sizes like in the order of gigabytes. With this system, you have two options. So go through the web browser, and let's say when you have a small amount of data, you can go through the web server interface and go land into the NFS storage. Or you can go through S3, and this is interesting because you end up staging into the data into the S3 bucket without having to run anything in the backend.
So what's the difference between a little data and a large data in this context? Are we talking gigabytes? Or?
Yeah, this is gigabytes as an input, but it's going to be multiple hundreds of gigabytes as an output. So when you have the results, you have two options. So you can say, okay, I want to keep into the S3 bucket because I'm going to reuse it at a later time.
Because you might tear down the cluster.
Yeah, might tear down the cluster and reuse it at a later time. Or you can even download. This is going to take more time, but you have the option to do that without having anything running in there.
Well, so 3D application streaming, ephemeral spot clusters, for doing HPC workloads, persisting your data on S3. It's kind of a perfect cloud use case, and it sounds like it's enabling huge cost savings and efficiencies in the industry. So really excited to see this, and thanks a lot for sharing this with us today.
Thank you.
Thank you.
And thanks for watching. This is My Architecture.